All right, last page of the review. Yeehaw. Well, it's pretty nice here, and I gave you a little word bank of options. Trying to get you guys to be a little less intimidated about these proofs. Well, first one, can use given. They said angle 1 and 3 are supplementary. Well, I know what that means. Means we're going to add up to 180 degrees. Looks like these are word banks for the reasons, because if they're using the linear pair theorem, my only linear pair up here is 2 and 3. That means they have to be supplementary. And I guess that's, yeah, angle 2, angle 3 are supplementary. All right, angle 1 is congruent to angle 2. If two angles are both supplementary, if one supplementary to 3, two supplementary to 3, it's technically called the congruent supplements theorem. We won't have that on our test, I'll make sure. And then lines have to be parallel. Got to be ready for this converse of the corresponding angles postulate. Next, now be careful, there's two parts to this given, and they've only brought one idea up so far. Look, they're going to be bringing up the other part here. But if P is parallel to 3, they're saying the alternate exterior angles theorem. Where's my alternate exterior angles? That's right here. Alternate exterior angles says they are going to be congruent. Well, I've got a linking set here. If 3 is the same as, 1's the same as 3, 3 is the same as 2, then 1 and 2 have to be the same. That is a transitive property. And because of the transitive property, I now have some corresponding angles that I've proven are congruent. Again, this is the converse of the corresponding angles postulate. All right, let's take a look. Two pieces, they didn't use any. I think it's all going in here. R is parallel to S. 1's congruent to 2. Why does 2 have to be congruent to 3? Well, they're corresponding. We do know the lines are parallel, so that's the corresponding angles postulate. If 1's the same as 2, 2's the same as 3, then 1's the same as 3. That's the transitive property again. And we know what our last statement's got to be. It better be what we're trying to prove. Line R better be perpendicular to T. You might see some of these proofs on the test. Yeah, I would study these pretty closely.